This is grade 12 University Physics, Unit 3, Electric and Magnetic Fields, Lesson 11, Magnetic Force on Moving Charges. Specifically, today we're going to look at the mass spectrometer. So question, calculate the mass of oxygen-16 with a charge magnitude of 2e, accelerated into a mass spectrometer through a potential difference of 325 volts into a uniform 2 Tesla magnetic field. The oxygen ions occupy a curved path of 0.862 centimeters. So let's look at what this mass spectrometer actually does. Initially, it's going to fire some electrons at the oxygen atom, stripping away some of its electrons, causing it to be ionized and therefore to have a charge. Then we put this charged oxygen atom between two parallel plates. And I literally drew two parallel plates. That's not actually the case though. But these plates will have a charge and therefore a potential difference between them. That potential difference will cause the oxygen atom to accelerate and reach some maximum speed before leaving the parallel plates. We can calculate this final velocity that the oxygen atom will have by looking at the work done by the parallel plates, which is the charge on the oxygen atom multiplied by the potential difference between the plates, and that'll equal our change in kinetic energy, where we'll assume the initial energy was 0. Once leaving the parallel plates, the atom enters a magnetic field which is perpendicular to its direction of motion. This will cause the atom to actually enter a curved or circular path of radius r. And this is due to the magnetic force causing circular motion. And we can substitute that equation where magnetic force equals centripetal force. A magnetic force is QVB, sine of 90, where sine of 90 is 1, equals mv squared over r. Now using these two equations, one for the motion of a charged particle in an electric field, and 2 for the motion of a charged particle in a magnetic field, we can solve them for two unknowns. Rearranging the electric field equation for velocity, substituting that into the magnetic field equation, square both sides, cancel some variables, rearrange for mass, and substituting all of our known values will give us the mass of the oxygen-16 atom to be 1.45 times 10 to the minus 25 kilograms.